Can you all guys hear me right now? Okay, so good evening to everyone. Let's get started. So first of all, I will tell you a short summary what we have learned yesterday. Then I request one by one to open your screen and share me what you have done till now. So coming to the initial part where we have discussed how to take a drugs from any database and how to download the protein in PDB form. And then we also learned how to predict the active sites of any protein. So let me show you one by one. So as we know, for docking part, we require two things. One is your protein, and second thing is what? Your drug molecule or your you can ligand. Okay. So for protein, you have to go PDB, protein data bank. I just type here PDB, that shows protein data bank. I just enter. You will get the homepage of PDB where you can search any protein that you know. So it can show you the PDB ID, the structure, for evaluating its structures, its angstrom value. It means each and everything mentioned yesterday, is very like they work in most protein most of the time. So they don't get their proteins on this database. They have to predict the structure of their protein, sequence of that protein on AlphaFold or Swiss model, and then download in PDB form, then go for active site prediction. So that's the another approach. We will also discuss the same that approach as well. But right now, just come to the simple one using the PDB. How I can download any protein. So this is the web page of Protein Data Bank, where you can see a search option is here. Just click here, or you can guidely show here. Just mention any protein. So yesterday we have taken RNA dependent RNA polymerase. There is a viral protein which is present in viruses, especially I guess dengue virus. Yes, in dengue virus it was present and it causes disease in humans. So let's take that virus. I just mentioned here RNA dependent. One second, guys. Someone is trying to join. Okay, I just mentioned RNA dependent RNA polymerase. And you can see a couple of results is being shown here. Meanwhile, let me show you how you can download the ligand till the search is on. So for downloading the ligand or your drug candidate, you have to go PubChem. You have to simply just type here PubChem. You will go to the PubChem database. The first link is shown here. Just click here. Name of your compound that you want to take as a drug. So for RNA dependent RNA polymerase, as I am quite familiar with this protein, so yesterday I instantly told that zidovudine is one of an antiviral drug that might get interact with this viral protein. So I am taking zidovudine as a drug for the docking perspective. Okay, but you can take any drug. Okay, whether it's not anti very low score, that's okay. But right now you are learning these skills. So when you perform actually, you can take the drug as per your convenience. Okay, so I'm just taking a zidovudine. And yesterday I mentioned about the Weaver's law and Lipinski rule of five. So where I mentioned that try to always take the molecular weight of your drug less than 500 gram per mole or Dalton. because if it is greater than 500 gram per mole, it violates the Lipinski rule of 5, and due to that, it won't get the FDA approval if you will work on any drug, or you can say as a, it cannot be go for the oral viability drug. So for that reason, you have to follow this thing, okay? And if you have heard the term log p value, which is a part of the Lipinski rule of 5, so can anyone tell me what is the meaning of log p in Lipinski rule of 5? Anyone? So I am going to tell you. Actually, it is a there is a four parameters in Lipinski rule of 5. Most people get confused. In Lipinski rule of 5, there should be five parameters, but actually it is not the case. In Lipinski rule of 5, there is four parameters, and each factor, if you focus there, like in each factor, you will see all are multiples of 5. That's why they were known as a Lipinski rule of 5. Okay, but actually there is only four parameters. So what are that four parameters? First one is that the molecular weight, which must be less than 500 Dalton or 500 gram per mole. Okay. So if your drug is of higher size, so it may takes lot like more and more times to break it. And also if you heard the term, like especially in pharmaceutical biotechnology, if you consume a drug of 500 gram per mole, so your body will only get 250 gram per mole. Okay, it means whatever the drug you have been consumed, only 50% of that drug is being used by your body, rest all being discarded. Okay, so if like if you have heard that also in many tablets it is mentioned 600 mg, 500 mg, so 600 mg means what? Your drug is consisting of 600 mg, but your body will only get 300 mg. Okay, that's the reason. So that's why always there is a certain protocols has been made in Lipinski rule of 5. If your drug is greater than 500 Dalton, it required extensive, forces for the breakdown and going for the absorptions and distribution and metabolism part, and sometimes it causing the obstruction. Therefore, the best way is what? To reduce the molecular weight below 500. Second thing is what? Log P value. Again, it same based on the same parameters, where it tell you the partition coefficient of the lyophility, and the main thing is that it again have a good role in oral viability. Okay, for any drug to be taken as a oral drug, log p value must be less than 5. If it is greater than 5, again it causing the hindrance in the absorption pathways. Okay, therefore it must be less than 5. I hope I am clear with this. So coming to the next one, I have downloaded here like the protein part I have searched here, and still it is ongoing. Now coming to the PubChem, which is drug, as you can see here, it is shown here. So I have to just click here and downloading the STF file. For protein, I have to go for the PDB format. For drug, I have to go for the STF file. And once I downloaded these two proteins and drug, I have to convert both of them into PDB QT form. Because I mentioned yesterday, Autodoc Vina can only read the file that are is in PDBQT. Okay, I'm so sorry. Let me know, is it fine right now? So, what I mentioned ki once you download your protein in PDB form and your drug in STF file, you have to convert your drug and protein in PDBQT form. So for that, you have two options. First is either you can use the OpenWabble, or you can go for the Autodoc tool itself. And second is either you can directly use the command line. So I will try to show you both the ways how you can convert your drug or protein molecule into PDB-QT form. But before that, also we have to predict the active sites because it take quite longer time for prediction of the active sites. So what I told, okay, as right now my voice is still breaking. Okay, okay, right now is it coming fine? Okay. So actually what I was telling ki you have to convert your protein and drug molecule into PDB-QT form. For that you have two options. Either you can use the tools like Autodoc Veena itself, or you can use the OpenBabel tool. And second way is what you can use the command line base. So I will show you the both the things. But meanwhile, let me show you how you can do the CAST-P analysis, where you can use the protein for its active site prediction part. So I have to upload here protein. Just click here calculation. You have to upload your protein here and just click on the submit. You will see what are the active sites that is present in your protein like this way. Okay, and for downloading the result, I shown you, you have to click on the download. Your result will be getting downloaded. Okay, so once you do this much thing, you will get a output file like this way. So you have to open this file, and inside it there is different number of files. Let me show you. I think 5 or 6 file is there. So you can see there is a 6 file is there, and you required only the POC file. Okay, not this one. You required only this file, POC file. Remember my words. It you required only POC file because it contains the active residues only. And this the POC info file, it consists of more information which we do not want. We want only POC file. So I just click on POC file. So whatever the informations of active sites, right now it is being displaying here. I just copied all the information here and try to paste in an Excel sheet. Okay, so I just click on blank workbook and paste all my data. I think it haven't copied well. So again, I'm copying the data and pasting here. So can you guys see now all the data has been copied in this Excel sheet. Now I have to do one more thing. I have to distribute this thing. So for that, just go to data, and what I did, text to column things I mentioned here. So here I think only one file has been copied here. So let's do it once again. Copy. So now you have to select the column A, go to data and click on text to column and click here finish. Now it is distributed in all the columns. Now I want only this two column D and column F. So right now I'm coloring this column with yellow color. Sorry, I'm not getting what you are asking. Could you repeat once again? Okay. Okay, so you have to select column A at the same time. Like for the first time, you have to go to the data and click on text to column. It will be done. If it is not done, let me know. You can record that screen time, like record that screen and let me know. I can help you in sorting that thing. Okay. So now, like I have to keep only this yellow columns. Rest all I have to remove it. So I'm just deleting each one by one. Yes, and you will understood the reason soon why we have did this thing. Uh, but for that you have to wait. So now I have just keep the, only these two column. Now again I have to select column A and go to remove duplicates. Again, I'm repeating, I have to select column A and go to remove duplicate option. And here automatically it selects expand the selections. And now you have to click remove duplicates. So now it will remove whatever the duplicates, active sites is there in this list, all will be removed. Okay. So I just click remove duplicates. Now it will shows column A and column B from both. Here you have to unselect the column B. You have to only select the column A part. Okay. Again, I'm just focusing here. You have to select only column A part, unselect the column B, and now click OK. So as you can see, 1277 duplicates value were there, which is right now removed. So this is now your unique active sites, okay, in your protein. Now I'm just removing the color. So try to copy this data and paste in an Excel sheet. Sorry, paste in a notepad file. Copy this data and paste in a notepad. So yesterday I created a biotech name folder where I just created two more folder. One is your ligand and second is your protein. In ligand, I placed here SDF file of the drug, and in protein, I placed the PDB file of the protein. And now I'm just creating one more file, which is castp file, new, and go to text document. Just mention here castp, enter. Actually, already there is a name, same thing. So just replacing this one. So try to open it in Notepad, not in Word as I do. Let me close with this. Open in Notepad. Okay. Okay, just paste your information here. Okay. So these are all the active sites of your protein. Now let me focus here one thing. Like initially I will be focusing on the simple way of doing docking as like mostly people do using Autodoc Vina, where you can see in research paper which is published, they prefer this one. But if you go for a higher level, like using the script one, if you have thousands or millions of compound for docking, then you can go for the script one. So for that, you have to quite do changes here. So that I will let you know further, but you have to do certain changes here in this active sites, like this way. You have to remove this part and spaces. Okay. So methionine 273 comma. You have to put here comma and like aspartate 274 and remove the spaces. Same thing you have to do for all the active sites. And now save this file. So now while performing the docking via the script, you have to paste all this information there. Okay. So that's the thing that you have to do changes once you going for the script base. But right now we are doing simple mode, so we don't require these kind of changes. Okay. So I'm just saving this thing. Okay, now come to the next thing where I will show you how you can use the Discovery Studio for some more interpretations of your proteins, which can explore you different kinds of chain which is present in your protein and which chain is good, which chain is not. Okay, for that information. For that, you have to search. Yesterday, I told you how to download the Discovery Studio. So, is everyone downloaded the Discovery Studio, or is anyone facing the difficulty? Let me know, or can text me anytime so that I can assist him or her to download the Discovery Studio. Okay. So I'm just opening the Discovery Studio, which I have already installed. Okay, so this is the overview, you can say, interface of the Discovery Studio. You have to click on File. You have to click here, then Open. Now choose your protein where you have saved. So my protein is in Biotecon folder. Biotecon. I will go inside the protein folder now. And this is my protein 5IQC, which is RNA dependent RNA polymerase, which is found in dengue virus. So I just select this protein and open inside the Discovery Studio. Can you guys see this thing? Is Okay, so actually we are now going to use the Discovery Studio from which we can explore some more part about our protein, which is we are not familiar with it, like how many different kinds of chains and which chains contains the most active part and all that information. For that, what I have to do, you have to first of all install the Discovery Studio, then you have to click on File, then go on Open, and after that you have to choose your protein molecule wherever you have saved. So I have saved my protein molecule inside the Biotecon folder. There is one more folder which name is protein, and inside this protein folder I have saved my protein, which is 55QC. So I just select this protein and click on the open. So after that I am getting result like this. Is it clear? Okay, now if you can see here, there is one option, a short menu is like there. Can you guys see this one where right now moving the cursor? Okay, just click here. So you can see now it displaying some more informations like chain AAA, heteroatoms, water active sites, protein groups, and ligand groups. Okay, so actually, what the proteins you have downloaded from the PDB, it already consists of a ligand. And for docking, you have to remove that ligand from this protein. Then you can use for your docking part. Okay, because the protein that you have downloaded from PDB, it already comprises of a ligand within itself. That's why it shows here ligand is here. Okay, and if you will rotate here, for that, how to rotate this one and let you see whether the protein ligand is attached or not. Just double click here, and here you can see mouse mode. Double click here, you can see mouse mode. Now then click on rotate. Now I am rotating my protein. So can you guys see here there is a ligand, this yellow color in between of this protein. Is it visible to everyone? So this is the unintended part that which is already exist. Okay, but we have to remove this thing in order to take the purified protein. So for that we have to remove this protein. And how we can do this thing? With the help of the Discovery Studio. Therefore, we have to do the prior analysis using the Discovery Studio before going for the docking part. Okay, so I just click on this ligand, or I can say as a uncheck this one. Okay, if you uncheck this, ligand is getting removed. Can you guys see? Right now at this stage there is no ligand. Now one more thing you have to do, you have to also remove the water molecule. So these three droplets which you can see in red color, these are the water molecules. Now you have to uncheck this one because water will cause hindrance in binding. So you have to remove that water molecule. Okay, now this is your protein. So actually this protein is quite, you can say, as a simple one, or you can say as a like quite short one. Otherwise, if you're working on a long protein, you can see different chains like chain A, chain B, chain C, chain D, and all that. Okay, right now it is consist of only one chain, which is chain A. But if you are working quite complex protein, it consists of multiple chain A, B, C, D, E, F, G, H. So out of all the chains, you have to select only one chain which shows greater binding energy, or you can say as a greater binding affinity, and that you can interpret using the Discovery Studio. Is it clear up to here? Okay, so now the next thing what you have to do, just click here and let's see what is inside this A chain. What information that is present inside the A chain. So here you can see few information is there. Just click once again here. Let's stretch this part. Okay, these are the atoms which are present inside this chain, and these are the active residues, or you can, sorry, not active residues, I'm so sorry, these are the residues that are present in this protein. Okay, like methionine 273. But out of all these active residues, only few residues is there which is active, and which we have founded around 20 residues. So our docking will be done only at that 20 residues, not all these residues. So be clear about it. Okay, so this is the whole information that you are getting here. Let's close all this thing. Okay, now you have to do one more thing. After that, what you have to do, just click again on file. After doing what we have did, we have select the ligand groups. We have also unselect the water molecule. Now we are going to click on file. We are going on save as, and now change here Discovery Studio file to a PDB file. Can you guys see here? PDB file, protein data bank file. Automatically it will select as a Discovery Studio file, but we have to change it as a PDB file, protein data bank file. Okay, and just quite do changes in its name. Otherwise you will get confused because two file with of same name. So I just mention here 55QC underscore. Okay, yeah, 55QC 1. Okay, something like that. If you mention here underscore and at the rate and something like that, in Autodoc Vina, the tools cannot interpret this protein and you will get certain error. Okay, so don't try to give certain names which cannot interpreted by the tool. So give it a simple name. Okay, if you there is a multiple chains and you are selecting only one chain, for example chain A, so you can also write like this way, 55QC underscore A. This is also one approach of writing it. Okay, like I have working on chain A, therefore I have written underscore A. Now click on here save. Now my protein has been saved. Can you guys see the changes in the size of the two files? Initially it was of to 435 KB, and right now it is of 388 KB. So that means some changes has been done in us inside our protein. Now one more thing I just forget to mention in Discovery Studio interpretation. Let me show you if it is work. Just click like this is the protein, and now we are going to explore its active sites. Okay, now you have to click on define and edit binding site, and go for from receptor cavities. Okay, let me check it. Oh, sorry. Okay, just wait a second. Can you guys see a ball is being made here? Okay, so this is actually the things that we have done using the cast. Oh, someone still try to join. Just a second. So the thing that we have done using the Caspi tool. Same thing we can also do here, just via Discovery Studio, but in a different way, and also it gives quite extensive knowledge as well. So this ball defines that what are the active parts of your protein. So whatever the part of your protein that come inside this ball, that shows the active part, okay? And the part of the portion of the protein which is outside of this protein, that are the quite inactive parts, okay? So your docking will always try to be done in this active part which is inside this ball, okay? Am I clear with this? It means between the center of the protein, okay? Sometime it will show at the terminal region or at the corner part. Is it clear? Okay, yes, yes. Actually, you have to click on define and edit binding site. Then you have to click from receptor cavities. From receptor cavities, okay? And you can also do via the from pdb side records, but right now I don't want to confuse you all. I just want to keep it as simple as you can understood. Initially, if you can perform like 5 to 6 talking, then we can go for the exploration of all these options in detail way. Even right now I'm telling you the very basic things. I'm not going in detail, but I can also like let you know like what are these at sites 1 to 16, what are the information about this one. Like if I click here, you can see different more information is there, okay? So what is the meaning of that? So we can understood this thing later once we perform all the docking part. You can say the simple thing is over, then we can go for the technical things and understanding in better way. So now the like protein part is quite done. Let's close this thing, okay? So now I have this my protein which is in 5iqc underscore a in pdb file, and in this folder, ligand folder, I have my drug in STF form. Now just come to the Autodoc tools where I can convert these two things into PDB-QT form, or either I can also do via the command line way. Okay, so I think just go first of all with Autodoc tools via. So I have download. Okay, did you guys have downloaded MGL tools, or how many of you are unfamiliar with this term MGL tools? Okay, okay. I'm so sorry I haven't informed you earlier. So you have to come on Google and search MGL tools. You have to search here MGL tools, enter. Okay, now you have to click on the first one, the Scripps Researcher one. Okay, so it takes quite longer time. So what you have to do, I will show like I will paste a short video how to download the MGL tools. You have to simply go and search on any browser MGL tools. You will get certain selection parameters. Like for Windows, just click on that one for Windows installation. Once you download, you will get an execution file. After that, run that execution file, your MGL tools will be installed, and always install on Windows C drive, because docking require more information for performation. So please try to go for Windows C drive. Okay. I hope I am clear with this. So like for all the analysis which we'll do by tomorrow. Okay. From Angel Tools part. Now let me show you if I can via the command line. Okay. Because it's quite simple and easy. So this is my drug here. I just click on the search box of my laptop here, command prompt. So right now command prompt is open, and I already give this information that this command prompt will open in Windows C drive. Okay. And if you don't know how to do this thing, so let me know. I can help you each one by one how you can give this path automatically that it can directly open in C drive. Now you have to click here and copy the address of the drive where right now you are working, because command prompt is right now open in the C drive. But we have made our folder inside the C drive. There is another folder we have made biotech and inside the biotech we have folders like proteins and ligand. So we have to give the address that right now where we want to work. Okay, so I just click here, double click here, I copied copy address, and now I have to paste this address on command prompt. So directly you can't paste this and control plus V here. You have to double click here. Okay, double click here. So my address is being pasted here. Just try to enter. So right now what is happening here, the address that I am pasting here, it is not being responded or it is being not recognized by them. So what you can do, just mention CD. CD stands for command change directory. CD stands for change directory. It means right now this command prompt is open at this location, C users and Anand. But right now I'm changing the locations, or you can say the directory, from this path to different path to CD, and now then mention the address that we copied. Now again enter. So right now you can see the path is right now changed. Did you guys understood this thing, whatever has been done here? Anyone who did not understand what the things that is being getting here, please let me know. Because you both have to perform via the command line as well as the Autodoc tool. But if you want to do for multiple compounds within the command line, it can be done within a second. But if you do via the Autodoc tools, it will take 1 day or 2 days for doing a single drug. You know, if you have 1,000 drug, it will take you 2 days or 3 days for converting into PDBQT. And also if you go via the tool like OpenBabel tools, like you have to install OpenBabel tools, convert into PDBQT, then again via the tool, it do not follow, you know, certain criteria which we can do here via the command line. That's why command line is always preferable in any type of analysis, especially for the bioinformatics. If you do same thing via the any web based tools or web servers or any app based tool, and if you do the same thing via the command line, so always researchers, or you can say as a scientist, prefer the command line as compared to all these web server kinds. Okay, web servers, or you can say as a app based tool. So now what I have to mention, I have to mention a single command. What is that command? Let me try. Also I didn't remember as this moment of time. You have to mention here O Babel star dot star dot stf. I will explain you what is the meaning of this command. So please hold for a moment. STF minus O PDBQT. Okay, let's try whether it's work or not. So something is being running. So as you can see, the changes has been done. The result has been shown here. Can you guys see? Okay, so now the file is converted into the PDBQT form, okay? But the result is itself displays on the terminal. But we don't want this information on the terminal. We want this information into a file, right? We want this information into a file. We don't want into a terminal. Now we have to do certain manipulations in the command so that we can get this output file into a output informations into a file, not on this command like this panel, okay? So what are that changes? Let me do. So you can mention like minus m, okay? Just try with minus m first of all. Let's see whether it's done or not. Okay, so it's done. Okay, if I mention here minus m, the file is converted. Okay, and how I can get to know ki, like my work has been done, because I'm getting this one C colon then forward slash biotech forward slash ligand and this thing. Okay, so that shows the command has been done right now. If the command is executing, you won't get this thing. Are you guys getting right now how you can go understood whether the command is running or not? Yes, yes. Each and everything I will explain you. Just please hold for a moment. Okay. If I do not mention here minus m, as you can see here, I get the output here on the panel itself. Okay. But if I mention here minus m, I get the output into a directory, into a file base. Let me show you how it will come. So you can see one another file has been formed with the name of pdbqt. Can you see the reduction in the file size? Initially it was of 6 KB. Right now it is of 3 KB, and the size reduced, the file format is being converted from STF to PDBQT. Can you guys see this thing? So that's why we have done here minus q. But how I get to know this command and all that? You have a lot of question regarding that. What is this CD and all that multiple things? Okay. So let me explain you one by one. Uh, OBabel stands for Open Babel. Star.stf. Star dot means कि whatever the address that we have provided in command prompt, it will read all the files. Star dot means it will read all the files that having a file format of stf. Okay. Star dot means what? It will read all the file. Okay. And which file format it can read? The stf file format. That's why I mentioned here star dot stf. If you have if you don't want to use start dot, you can typically mention your file name only and minus, then mention the next part. Did you guys get what? Why do I mention start.stf? Means it can read all the files, okay? But which file the command can read? The STF file format. So whatever the STF files whatever the different kind of STF file is present in that folder, this command can read all that files, okay? Now I mention here minus o. Minus o stands for output, okay? And which file format you want to get? In PDBQT. So I mention here minus o, then PDBQT. Now, once I run this, I got the result on this panel itself. But if I mention here minus m, so it will compile this result into a file and give me as a PDBQT file. That's why we have used minus m. Okay. Is it clear? Okay. But now again, certain is left because you all are researchers or you all want to become a researcher or scientist. So you have to understand more and more thing about that. I request everyone to go through this thing. I'm going to show you. Right now, I'm going to show you. You have to just type here Open Babel commands. Or you can also search the same thing on GitHub if you don't know what is GitHub and all that. So initially I will show you the basic thing. So here you can get all the commands there, okay? And try to read and understand what are the basic commands of OpenBabel. Although you require only this thing, the file conversion one, but please try to explore some. So right now taking quite longer time. Let's back to here. So same thing I will do for the protein part, okay? I have to convert my protein into PDBQT form. So again I have to mention here CD. Can someone let me know why I'm mentioning here CD? Can someone, yes, from where to where I want to change the directory? Like initially I was in ligands directory, but right now I'm going to change my protein into PDBQT. Therefore, I have to change the directory from ligand directory to protein directory. Am I clear with this? That's why I mentioned here CD. CD stands for command, sorry, change directory. Okay. Now I have to again double click here at the top and copy the address. Double click here and copy the address. And yeah, I have to paste here on in command prompt. Enter. Like just double click here. I don't know why it is not being getting done. Copy it once again. Okay. Now just enter. So you can see right now the path has been changed C biotech and directly it's come to the now protein. Initially it was C biotech ligand, but right now it changed to C biotech protein. That states that now directory has been changed. Now again I have to read the same command. So you have to write the same command, but how you can write? You can just mention the up, just click the upward button of your laptop, okay? So once I click upload button, it will shows whatever the command that I have run so far on this panel. It will shows all the command. If I will click the downward button, it will shows whatever the command that I have run till now. Okay, in the same format. Okay. So I have run this way. I think this command I have run here. Okay, but I have to do certain changes like this thing, because right now my file is in PDB form. So is it clear to everyone whatever I have mentioned till now, especially in this command? Obabel start.pdb minus opdbqt minus m. Right now I'm getting commanding this program कि whatever the file that I have in pdb form, okay, it will convert into the pdbqt form. So I have two files. First is 55QC, second is 55QC underscore A. But my original or my final file is 55QC. So you can delete this file 55QC because we don't need this file, because this file contains some interruptions, or you can say unnecessary information. So let's delete this file. I have now I have this manipulated file which is 55QC underscore A that we have saved from the Discovery Studio, which consists of only the protein parts. It does not consist of heteroatoms, or you can say the water molecule. So it does not consist of water molecule and ligand molecule. Okay, it consists of only proteins and heteroatoms and protein groups. So now I just click here, enter. The command will execute it. So now the command is being running. Just wait for a second. So it take quite longer time. I don't know how much time will it take, but it takes around 3 to 4 minutes maximum. Okay, so that's all for today, where I will show you how you can use Discovery Studio for the interpretation or for the analyzing your protein. Next thing I told you how you can convert your PDB file or SDF file into PDB-QT file using the command line. And one more thing I told you how you can download the MGL tools. So make sure you all have to download the MGL tool so that we can use that MGL tools in the next class, okay, for doing the same analysis, for doing the same thing. So am I clear with this? If you have any question, please let me know, or you can also type in that WhatsApp group so each one of us can familiar with that one. Or if there is any suggestion for me, please let me know, like my speed or something else. uh, yeah, sure ma'am, sure. Yeah, okay ma'am, sure, sure. I will make a video on that also before the class, so that everyone can download the tools. Okay, I will remember this thing for the next time. Okay, anything else? Okay, so I hope everyone have understood whatever I have told till far, and tomorrow I will request everyone so that each one of you can share the screen and let me know whatever the things that you are getting right now, and you can able to perform the same thing by presentation as well. So each one will of you get around 10 minutes so that everyone can present whatever he has learned, like active site predictions and conversion of the file formats and using the Discovery Studio. And once you all have done up to that stage, then we can move further. So that's all for today. Thank you for joining the class. So now I'm going to end the class. Bye. Good night.